and welcome to Teacher Gimbal channel. Today we'll be going over Illustrative Math Geometry Unit 1, Lesson 13. If you like this video, please like and subscribe. If you want to have personalized videos on any topic of mathematics, from K to 12th grade up to AP Calculus, Statistics, SATs, you can find a link in my bio to my Patreon. If you subscribe, I'll make your personalized videos basically as often as you want, depending on which subscription you choose. Anyways, check it out if you want videos of your own, and I'm happy to do other illustrative math content or the lessons if you need as well. Let's get started. Problem 1. Here are two polygons. Select all sequence of translations, rotations, and reflections below that would take polygon P to polygon Q. Now, I'm working on a computer, so I don't have tracing paper, but I would definitely pull out my tracing paper if I had some. And the first thing I do is I say P is going to Q. And that's important for me to draw because just to make sure that I'm moving in the right direction, because P to Q would be a different sequence of transformations than Q to P. So I'm going to check all of my answers now. A, rotate 180 degrees around point A. So what I like to do is I like to think of one of my lines right here. So if I took this line and I rotated him 180 degrees, he would end up over here because that's 180 degrees. That is exactly where I would want him to be. So I'm pretty sure that this is the correct answer. Now, I'm just going to double check to make sure that I'm correct by looking at a different point. If I'm rotating line EA, and I'm going to rotate him 180 degrees around point A, well, he's going to go all the way around, and he's going to end up over here somewhere, which then tells me maybe I'm not correct. So it's good that I checked my second point. And I need to cross out A as an answer. So it is not A. Let's cross them out. Let's go on to answer B. Rotate 60 degrees counterclockwise around point A and then reflect over the lines FA. So I'm going to be rotating 60 degrees. So he's going to rotate 60 degrees, which lines him up over there. He's going to rotate 60 degrees, which is going to drop him somewhere over there because it's 60 degrees over. And then we are going to flip over. Well, if BA lines up over here and we're flipping, this dude is going to come over here somewhere. And we don't want this dude to be over here. We want this dude to be all the way, well, we actually want him to be lined up right there. So this side lines up with that side when we do that rotation, and it does not work. And I do understand, so let me go over that clearly again. So if I'm rotating 60 degrees counterclockwise around point A, so this guy rotates 60 degrees, and I know this is 60 degrees because each triangle measure here is 60 degrees. This line segment lines up on this one. I'm then going to take this shape and I'm going to flip him over, but these two line segments do not correspond, so we're not going to end up with a shape in the right spot. Now, this is a very visual thing. If you are less of a visual person, I highly, highly recommend that you pull out your tracing paper. C, translate so that A is taken to J. So A is going to slide down to J, which means B is going to kind of be over here. Everything's going to slide over. And then translate it, and then reflect over line BA. Well, this guy's going to slide up, so he's going to be here. And when we flip him over, well, these two lines line up. This guy who is slid up over here, well, he's going to be flipped and go over there. This guy, he's going to be slid up. He's going to be about over there. And when he flips, he's going to go over there. This guy looks correct. So I'm going to give him a circle. And again, I do realize that I'm not using tracing paper, but starting to visualize these is an important part of this process. D, reflect over line BA, then translate by directed line segment BA. So we're going to flip over BA, which means this line right here. So this guy is going to end up looking, he's going to come down. This guy is going to be up. And then he's going to come over this way. It's going to be like this situation. It looks kind of like our actual shape. And then he's going to get slid up in this direction, while the BA is going to line up with AJ, which is what we want. And then this guy, who's the this guy lines up with HJ, which is correct. And I think this is our correct answer right here. So I'm going to circle it. Again, use your tracing paper to double check if you don't have this visualization down. Reflect over line BA. So we're going to reflect. He's going to end up over here. We're going to end up down here. It's going to be a similar type shape like what we had, right like that. And that's a little bit better. I think I made him too big. And then rotate 60 degrees counterclockwise around point A. Well, when we rotate him, that's going to mess up our shape. It's not going to be lined up with our original shape. So that is incorrect. So the answers to this question are C and D. And take a second and try it on your own if you need help with visualizing. Let's go on to problem number 2. The semaphore alphabet is a way to use flags to signal messages. Q. Here's how to signal the letter Q. Describe a transformation that will take the left-hand flag to the right-hand flag. Well, the left-hand flag, first we're going to have to rotate him. And we're going to say we're rotating around point P. And so we're going to rotate, that looks like about 120 degrees. So we're going to rotate 120 degrees counterclockwise, because remember, this is our clock. Our clock goes in this direction, so that's clockwise. If we go backwards, that's counterclockwise. And then L is going to be lined up right here. That's going to be our L flag. And so we're going to reflect over this guy's right arm. So one, we're going to rotate 120 degrees counterclockwise around point P. Then we're going to reflect over the dude's right hand. And that's going to line up the two flags. Or it's going to get flag L over to flag R. All right, pause if you need to go over this as I go on to the next question. Match the directed line segment with the image of polygon P being transformed to polygon Q by a translation by that directed line segment. All right, so we got 4 translations and 4 directed line segments. And can we get them all on the same page? Nope, it's going to be difficult, but that's okay. So translation 1, we're going from P to Q. So I always identify one point. P is going to Q. And that far over, I'm going to scroll down and I'm going to say, which guy matches? Well, it matches right with this guy. So translation 1 is going to be D. Oops. Let's go on to the next question. Translation 2, P to Q. He's going to go from here to here, slightly up. And what's kind of cool about scrolling down like this is we can actually see the line segment that looks exactly like that line segment because I am translating as I scroll down. So that line segment for translation 2, that was line segment, directed line segment A. Directed line segment A. So D, A. For translation 3, we're going P to Q. I'm starting here. The corresponding point is there. Let's scroll on down to find the correct one. He matches right there. So that's going to be B for translation 3. It's going to be B. And then our last one, we're going P to Q. So P down to Q. And I'm just using one point, but that should always work. You just have to make sure the point is corresponding. And he matches with translation B, which is pretty cool. I actually like that a lot. So this is going to be C. And we've done. So translation 1 is D, translation 2 is A, translation B is 3, and translation 4 is C. Let's go on to the next question. Problem number 4. Draw the image of quadrilateral ABCD when a translation by the directed line segment V. Label the image. A is A prime, B is B prime, C is C prime, and D is D prime. So he's going to go down 3 triangle lengths right here. So we want to go down 3 triangle lengths, 1, 2, 3, C prime, down 3 triangle lengths, 1, 2, 3, B prime, down 3 triangle lengths, D prime, down 3 triangle lengths, A prime, and there's our new shape, which looks just like our old shape. And that's it. Let's go on to the next question. Now, I can't move side by side like that, but as you can see, if I kind of brought them up and over, we'd actually be able to see how these two shapes lined up. 5. Here is line L. Hello, line L. A and B would stay in the same place when they are reflected over L. Plot 2 points A and B. Well, we know the only ones that stay in the same place with a reflection are ones that are on the line of reflection. So those A and B would stay in the same once they're reflected over line L. Plot two other points, C and D, which move when they're reflected. Well, C and D would move because C would go over to here, D would go somewhere over there. And we're done. Next question. Problem 6. Here are 3 points on the plane. Select all the straight edge and compass constructions needed to locate the point that is the same distance from all 3 points. Well, we need to first connect all 3 points. Then we would need to perpendicularly bisect each of our segments. And then we would need to identify the point of intersection. So that was 3 steps. Connect all 3 points, perpendicularly bisect all 3 sides, and then connect the point of intersection of those bisectors. Construct the bisector of angle CAB. No, we do not need to do that. Construct the bisector of angle CBA. Nope. Construct the perpendicular bisector of BC. Yep. Construct the perpendicular bisector of AB. Yep. Construct a line perpendicular to AB through point C. Nope. Construct a line perpendicular to BC through point A. Nope. And we're done. Those were the only 2 things on this list that we had to do to find the point that is the same distance from all 3 points. Let's go on to problem number 7. Oh, this is our last problem. This straight edge and compass construction shows quadrilateral ABCD. Is ABCD a rhombus? Explain how you know. First, we need to know the definition of a rhombus. So a rhombus has 4 sides that are congruent. So CD would have to be congruent to DA, to AB, and to BC. Now, we know that we have this circle right here. We'll call him circle C because C is the center. And this is a radius of circle C, and this is also a radius of circle C. So those 2 guys are congruent. Now we're going to stop looking at circle C, and we're going to look at circle B, which is right here. And we know this is a radius of circle B, and this is a radius of circle B. So those guys are also congruent. So we got 3 of the 4 sides. For our last side, we're going to go ahead and we are going to look at circle A. And we know this is a radius of circle A, and this is a radius of circle A. So those 2 sides are congruent as well. So yes, all 4 sides are radiuses of the same circles. And so they are all congruent, which makes this a rhombus. All right, if you have any questions, please put them in the comments below. Please like and subscribe with the button all the way in the corner. And again, if you want any customized videos on any math topic, subscribe to my Patreon and I will make you whatever you need. All right, I'll see you next time.